All right, today we're going to be talking about information disclosure. This one, like some of the previous ones, is going to be a little bit short. They should get a little bit longer as we get things moving more. But without any further ado, let's start talking about it. So, information disclosure is when websites unintentionally reveal sensitive information to users. So, obviously, right, different information holds differing levels of severity, and we'll kind of talk about that here in a second when we go over impact. But you know, it could be user data, it could be business secrets, could be details about the web application. But some examples, are hidden directories, personally identifiable information, PII, or public health information, PHI. I think those are the right acronyms. Source code backups. So, like if you still have your Git repository plugged in or your Git T repository easy to find, that would be a good example. Hard-coded API keys or credentials. If someone's able to dump usually you'll find that in source code, if you're able to dump it. But even so, right, you should assume that if somebody does have your source code, they can't ruin it. Um, Mentions of database tables. So like we saw that in the SQLi injection lab, and some of the other ones, right, where it mentions specific database tables, and we can actually use that information to make custom API calls and stuff like that. Other examples, right, are if it hints at certain technologies. So if it's revealing the name of the WordPress version or Apache or something like that, the version itself might not be, but also certain JavaScript plugins or miscellaneous things like that. Another question you might ask is, how does that happen? Developers might remove or might forget to remove internal content or references when they push things to production. Um, you also might find, that a website is insecurely configured. So like if a developer forgets to disable debugging or like draft pages from a blog or a website that's being pushed to prod, or you might see flawed behavior or design that lets attackers enumerate sensitive data through some other way. So let's go ahead and talk about impact. And the tricky thing with information disclosure and impact is that it depends. It depends on what was leaked, how much of it, right, and whether or not you can even actually figure that out is all going to depend on what the context is. So if you only deal with like I don't know, people giving you ideas, it's just basically like a comment board, and all you do is take someone's email address, and maybe they don't even need to log into your site. Not a big deal, right? If they just get some arbitrary usernames some people made up and that they can't even use over and over again, not a big deal. But if you're like I don't know, or a good example would be like, let's say you're a dentist, right? And somebody gets into whatever online mechanism used to store just the just like scans of people's teeth or X-rays. Like an attacker can't do too much with just the pictures of people's teeth, right? Like if that's all it is, they don't have names that allude to things. You just ID them by a number, and there's no markings on the images, right? You can't really. I mean, it's public health information, sure, but an attacker can't use that to further anything. All they're going to do is go on some kind of breach site and be like, hey, I have a lot of pictures of people's teeth, and I don't think there's a huge number of people on the web that are going to pay top dollar for that, so I doubt it'll be a huge deal. And you can't really, you could ransom that, but it depends. But at the same time, right, if that same dentist, their web application that tipped them off to the teeth pictures in this imaginary scenario, also lets them see, oh, here's all the records of all your customers, here's their first name, last name, mailing address, shipping address, billing address, whatever. Here's their credit checks that we did, and here's the results from it. Here's when their next appointment is. Here's their insurance provider, their deductible. If all that information is leaked, right, then you've got a much, much bigger thing to deal with. So the impact can have varying results depending on what information is breached and what information is actually disclosed to an attacker. So let's go ahead and talk about exploiting that, what that might look like, and the big thing I want to highlight here is intuition, or moreover, developing your attacker's intuition. So because sensitive data can be leaked in all sorts of locations, it can also like take the form of a lot of different things, as we kind of like went over a little in our example. So a really important skill to have is having the intuition to recognize things that are interesting or useful when you see it. So like when I first started doing like CTFs and stuff, I didn't really know what the hell I was looking for. People basically had to tell me like, oh yeah, that's an SSH key, or you might want to look in the etc password file because then you can figure out some usernames. But I didn't have the intuition at the time to know that because I just didn't really know yet. So over time, as you find these things, try and build upon this intuition that you're making for yourself. Um, and there's different ways you can actually go about finding this information. I highlight fuzzing here, and fuzzing is really a super generic term, but it's directory names, argument names. If you're testing a certain function on a website, maybe fuzzing one of the parameters of a GET request. It just depends, It depends on your context, but that's something you can look into if this is your first time. Also, utilize Burp Suite. There's Burp Suite Professional has some good features. So does the Community Edition. You could use, the scanner, I think is in pro version, but there's also, community-driven plugins that are super useful if you're trying to be more specific. Or you could just straight up use, the intruder if you're trying to fuzz stuff that way. And you want to have a little bit more details without using the command line too much. You could also go about generating informative responses. So like, getting a verbose error message that might show you more than you need. So those are places you might find this stuff. Where you might look or what it's going to look like. You might find files for web crawlers like, robots.txt. You might disclose a few endpoints or something like that. You might find some directory listings, just in the source page source. There might be comments in page source that show you passwords or usernames, or maybe from the developers themselves, right, referencing other parts of the API. Error messages might disclose some information. We saw that in some SQL stuff and authorization stuff. You can use error messages to figure stuff out. If they're using some kind of weird third-party tool to develop their web application, there might be like, an insecure configuration setup, or there might be some debugging endpoint that they forgot to turn off. There also might be, user account pages that you can mess with. In short, like if you can look at other people's accounts, right, you might be able to just determine other things about those users that might be, in the same way you can look at your own personal information, you might be able to look at somebody else's if the site is configured poorly and disclose that information. And then you could repeat that process for all users and dump that stuff. So there's also like backup files or like version control stuff. So if the GitHub or Git repository is somehow able to be exfilled from the actual web application, that's kind of a big deal, right? Because now the attacker knows the system, which you should assume they know the system anyway. But at the same time, them having your source code, if you didn't, it could be a pretty big deal, because then they can more efficiently map out the attack surface and figure out where those weak points are. But without any further ado, let's go ahead and hop into some of our quizzes. We're going to have the first one, which is Hack the Box Cache, and then the second one is going to be Vessel. So we'll talk about both of those, and then we'll come back here and go over the prevention strategies. All right, so I've got the Hack the Box machine called Cache booted up here. And I'm just going to throw, I've already done this before, and we know it's a web application, so I throw its IP address in here, and you can see it looks like some kind of blog news page kind of thing. If we go ahead and just start, looking around, right, we see like author HTML, login, and this one's pretty straightforward. You look at the page source. Okay, we see some stuff from Bootstrap. The version of Bootstrap might be useful, might not be useful. It really depends. But there's a few other things here, like net HTML posts. You might want to look at the source code of those. And you can see, obviously, right, it's a login page where we enter a username and a password. And down here at the bottom, you'll notice, let me actually zoom in because maybe you can't see this very well. Down here at the bottom, you can see functionality.js. Doesn't look like it's a part of any other kind of like library that's at least not standard, right? Google APIs, Cloudflare, like those are pretty standard. But if we look into functionality.js, I mean, that just sounds like a generic name. And if we look into it, we see it's actually just a really short function that talks about how the login page works. And it's not fantastic because it shows you in plain text here what the username is, which is Ash, and what the password is, which is have fun. So I'm just going to copy that to my clipboard, and we can just, let me zoom in a little, Ash and the password, say login. And I mean, it's some weird, like, I don't know, like in progress page. Later in the machine, you'll use those credentials, but that being said, it's just an example of information disclosure, right? It tells us this. There's another like kind of example on this page where if you go to author, you'll notice they're looking at a HMS hospital management system as like one of the projects here. And if you put cache.htb in your hosts file and then look for subdomains, you'll find hms.cache.htb, and then you can replay those credentials to get in there. So just a preview. We're not going to go that far just because I wanted to show you what the initial information disclosure might look like. The next one, Vessel, is going to be a lot more interesting. So let's go ahead and hop into that. All right, so I've got the Vessel machine pulled up right now. And we can, I think we can just start by pinging it. It should, yeah, okay, good. It's still my clipboard. If you run a port scan, I'm just going to do a simple one because I want it to return quickly. It's got HTTP open, so we can do some directory enumeration. Dir search is what I like to use just if I'm trying to be quick. U for the URL. And then what I'm going to do something special here, just because I've done it before, is we're going to use -r to say recurse. So as it finds directories, it will queue them up so that it can scan those directories afterward. So you'll kind of see what I'm talking about here. So it scans through, and you can see right here, right? It added JS to the queue. It looks like it's going through the login page. And directory enumeration, right? It's just looking for anything after the URL, so slash something. So there's a few login or admin pages that redirect you to log in. A few different pages. JavaScript looks like it redirects you to JS, or maybe 301's not a redirect. You can see here some interesting ones, right? Dev sounds interesting, especially if we're talking about information disclosure. So once this is done, which shouldn't take very long, you'll find out that it will start. As you can see, it starts the next task. I can do Control-C to cancel. It'll ask if I want to stop or go to the next one. I want to look at the dev one, so we're just going to do next until it lets us look at dev. So now you can see it's starting to scan through dev, and very quickly we notice references to a Git repository. You see a lot of different files that we can enumerate, and instead of trying to read through the source code, right, one line at a time, we can be a little bit smarter, and we can just dump this with a Python tool called Git Dumper. If you haven't installed it, I think you can just do pip install Git Dumper like this, or it might have to be Git_dumper. But you can see I've already got the requirements satisfied. So we're just going to do Python 3 -m git, and you can see my command history here. So I'll just go back here and replace the URL. So you just have to tell Python what module you're using, which is Git Dumper, the URL, which in this case is dev/.git, and then I'm just going to have it write to a folder called Git repo. Press enter. You'll see that it tests all of them to make sure they're there, and then fetches all these different objects. So if I clear this, you can see that this file or this folder is now populated. And you can see right there's our Git repository. There's our Git config, and there's a few different things we can do. If we want to do some stuff, let's first just do git log and see what comments have been put. So you can see this first log has some potential security fixes. This one also has security fixes. And then there's this initial comment from a while ago. So what I want to do is see what the difference is between security fixes and potential security fixes. Just because if we did initial comment and security fixes, or initial in this last one, it's going to show me every change that that's been applied since then, and that might be a lot. So let's just go ahead and look at the difference between this one and this one. So all we have to do is just remember the first couple characters of these. So it's EDB and 208. So let's do git diff EDB and 208, and that should be enough to show me the difference. Or is my syntax wrong? Maybe I do need more. EDB, let me think. I've got it on my other monitor here, so it's fine. Let's try 18. There we go. And we can see what was changed between the first one we listed, which was the security fixes, and the second one, which was potential security fixes. And you can see that the changes made here were, it looks like they made some change to, what is it, MySQL, upgraded, deprecated MySQL.js. But you can see that the database, okay, you can see how it connects, and you can also see that the config directory has a database.js file. So because of the security fixes, it might be interesting for us. So let's, I think we can just look, yeah, so we can just go to the config file, and we see that db.js. Let's just do cat, or we'll do nano in case we have to move around. And you can see right here, it looks like these are the usernames and passwords that they use to get into the MySQL database they're running. So this is a little bit more convoluted than the last one, but it's basically just they have their Git repository hosted on the same web server or the same domain that is just as easy to access as their web application. Not only that, right, they've got hard-coded credentials in there. So not only were we able to dump their code repository, but we were also able to see some things that shouldn't be hard-coded in. There's definitely workarounds for this. But that's basically it. You could use that information however you like later on in this machine, just because I don't want to spoil it and it's not part of today's topic. But that's all we've got for this machine. Let's just go ahead and round it back out with prevention. All right, so to go over prevention, basically what you want to do is make sure that developers are just aware of what information, right, they need to be considering as sensitive. So make sure that your security, if you're a big business, make sure that your security is working closely with your development team so that they not only know what's sensitive, but are kind of they have that open communication where they can ask questions to security like, hey, should I be exposing, the account ID number, or is that something we should be keeping on the down low? And it's like, it depends on the context, where is it being sent over, stuff like that. You also want to audit code for information disclosure. So if I can look into the source code, and if I look at the page source, is what I mean to say, and I can see like, I don't know, some kind of syntax for an API call, or maybe my GET request that I send looks a lot like an API call that I could just inject someone else's username info into, or maybe something like that. Generic error messages might also be something you want to stick to, because obviously, right, we couldn't use like any error-based techniques to detect problems with the application or get more information. So try not to use error messages generated by certain technologies. Try to just make your own and make them as simple as possible, so they don't reveal additional information. Double check, right, that your debugging features are not enabled in a production environment. So, obviously you don't need debugging in production. That's only for development. And then, if you're using a third-party technology, so if you'll see this a lot with WordPress. A lot of people who use WordPress use it because it's easy, and that's good. That's the customer base. But a lot of them forget to update their site, and so they're using a vulnerable version of WordPress that could have a lot more issues than it's worth. And so, it's just kind of a contextual thing. But with that being said, that's really all we've got to go over today. Pretty short video, but that's all we got. So see ya.